Every journey has a beginning and an end, and so is the case for cosmic objects. One among them is a red supergiant star, Betelgeuse. This star is nearing the end of its life and is headed for an explosion. Since the world's excitement about the mythical red supergiant's lopsided dimming and shrinking reached a fever pitch 2 years ago, the renowned Shoulder of Orion has attracted a lot of attention. This indicates that it's close to dying, but when exactly will the star kick the bucket? When is it expected to go supernova, and how will the Earth be affected if it does? Join us as we explore how Betelgeuse is finally exploding in August 2022. Movie stars, throwing stars, gold stars, and of course the stars in the sky are just a few examples of the various kinds of stars. The night sky offers a spectacular display of stars. Numerous stars make up constellations, which are still used for navigation today and were arranged according to mythology and stories. Betelgeuse, one of the biggest and brightest stars in our night sky, is one such star. Betelgeuse is the dazzling ruby-red sparkling speck of light in the top right shoulder of the winter constellation Orion the Hunter. Astronomers, however, recognize it as a seething monster with a 400-day-long heartbeat of regular pulsations when they look at it closely. Betelgeuse is easily recognized by its gloomy orange-red hue. It's perfect for persuading skeptics that stars do in fact come in colors. It is the second brightest star in the constellation after the blue supergiant Rigel and is also referred to as Alpha Orionis. Betelgeuse's changeable nature, in addition to its unusual name, makes it an equally fascinating object for star studies and observations. The brightest stars in their constellations are often those with the designation Alpha. Betelgeuse, however, is Alpha Orionis, even though Rigel, Orion's other bright star, is brighter. It is also among the most well-known stars due to its name, brightness, size, and reddish color. It's interesting to note that this star inspired both the film Betelgeuse and the character of the same name. Betelgeuse is the 10th brightest star in the sky overall, and it is the 7th brightest star that can be seen from the bulk of North America, Europe, and Canada. Numerous brilliant stars have Arabic roots in their proper names. This fact highlights how popular Arabic astronomers and astrologers were during the Dark Ages in Europe. The Arabic phrase that inspired the name Betelgeuse is typically translated as the armpit of the giant. Of course, the giant alludes to Orion, although some authors believe that Betelgeuse represents a hand or perhaps a shoulder rather than an armpit. Betelgeuse is marked on many old star charts as Orion's right shoulder. However, its exact meaning is unclear. It's hardly unexpected that most representations of Betelgeuse have an anatomical relationship, as Orion is most frequently associated with a giant, a warrior, a hunter, a god, or some other anthropomorphic or animal figure in ancient mythology. For instance, the Sanskrit term for what was probably a stag's leg also denoted an arm. Betelgeuse was compared to the foreleg of a turtle or the hind leg of a caiman, a crocodilian, in some regions of Brazil. On the other hand, Betelgeuse was regarded as a component of the rim of a ceremonial drum in ancient Japan. It is one of 4 vultures who are going to eat a criminal in Peru. Where is Betelgeuse? Betelgeuse is relatively close to Earth. Betelgeuse is thought to lie between 430 and 724 light-years away from Earth, while astronomers are unable to determine the precise distance. Due to its proximity to Earth, Betelgeuse is the brightest red supergiant star. There are only 200 red supergiant stars known to exist in our galaxy. In the Northern Hemisphere, the winter months of September to March are the best for spotting Orion and Betelgeuse. At dusk, Orion rises in the east and is positioned to appear to be lying down on the horizon. He gets up as the night goes on and hunts his way across the sky. Many people use Orion as a compass to locate other celestial objects because it's one of the easiest constellations to locate. For instance, Aldebaran, the brightest star in the Taurus constellation, will be visible if we create an imaginary line connecting the 3 stars of Orion's belt and extend it upwards. The Pleiades will subsequently be visible from there. In a similar manner, we can use Betelgeuse to locate other stars. Castor and Pollux will be indicated by joining Rigel and Betelgeuse and extending it past the red supergiant. The 2 brightest stars in the Gemini constellation are these 2. Betelgeuse's radius is around 764 times greater than that of our Sun. This star would extend past the asteroid belt and even beyond Jupiter if it were to take the place of our Sun in the solar system. This indicates that Mercury, Venus, Earth, and Mars would all be engulfed. Betelgeuse has a mass that is 16.5 times that of the Sun. With 126,000 solar luminosities, this supergiant appears luminous from a distance of 548 light-years. This star is colder than the Sun, with a surface temperature of 3,600 Kelvin. Visible light only makes up around 13% of Betelgeuse's radiant energy. However, Betelgeuse would replace Sirius as the brightest star in our night sky if human eyes were able to see light at all wavelengths. Every 10,000 years, Betelgeuse loses around one solar mass. This material is ejected unevenly from the star in all directions, creating a nebula that surrounds the red star. Betelgeuse is surrounded by a cloud of material that is 250 times bigger than this star. Additionally, it is estimated that the size of this nebula is 30 astronomical units AU, or 30 times the Sun-Earth distance. This is the distance in the solar system between the Sun and Neptune, which is the furthest planet. The red supergiant Betelgeuse is part of the Winter Triangle asterism. Together with it are some of the brightest stars in the sky, Sirius from Canis Major and Procyon from Canis Minor. Betelgeuse is thought to be between 9 and 10 million years old, which is just a young age for a red supergiant. Supergiant or red giant stars are assumed to be nearing the conclusion of their lives. Stars are formed of hydrogen when they are born, which, when subjected to intense gravitational pressure, fuses together in the star's core to produce helium in a nuclear explosion. Normally, the fusion process releases a lot of heat and light energy, which travels to the star's surface and is released as a photon into space. The star's fuel, hydrogen, runs out over time, and helium begins to fuse with carbon to make carbon. Carbon will then fuse into neon, which will eventually fuse into ion after the helium is depleted. When this occurs, the fusion of neon with ion no longer releases energy. Instead, it absorbs it. When iron starts to fuse, the star collapses in on itself as the force of gravity wins out, and a supernova explosion occurs because there is nothing to push back against the force of its incredibly strong gravity. One of nature's most potent forces, a supernova can produce more energy than 10 billion suns. Depending on which stage of their stellar evolution they have reached, stars change color throughout their lifetime, from the youngest, hottest blue forms to the older, cooler red types. Betelgeuse's color was interestingly described as ruddiness by the Greek astronomer Ptolemy, 90 to 168 AD, but 3 centuries earlier, Chinese astronomers had described the star as appearing yellow, possibly indicating that Betelgeuse was formerly a yellow supergiant. Larger stars often consume their hydrogen more quickly and die off sooner. Even though Betelgeuse is just about 10 million years old, it's obviously nearing the end of its life. On the other hand, at almost 5 billion years old, our Sun is still in its prime. Furthermore, it's likely that Betelgeuse will undergo a supernova shortly because it's nearing the conclusion of its life. The timing of Betelgeuse's supernova is a subject of much debate. There are 2 dimming and brightening cycles for Betelgeuse, with the first cycle lasting roughly 100 days and the second cycle taking place every 5 years or so. Astronomers think that during this cycle, the star's outer shell expands and shrinks, causing its circumference and average temperature to change according to each stage of the cycle. However, Betelgeuse attracted a lot of interest in 2019 and 2020 when it dimmed erratically before returning to its typical brightness a short while later. Astronomers hypothesize that it might be a sign that the star is about to die. Beginning in the 1st century BCE, Betelgeuse has been the subject of extensive research. More recently, a researcher by the name of Sarafina Nance and her group set out to determine when red supergiants such as Betelgeuse might erupt as supernovae. Nance and her team used Betelgeuse as a model and performed numerous simulations to determine how a star of that size would behave over time. They then compared their results to observations from the field. Betelgeuse has been observed traveling through the interstellar medium at a speed of 30 kilometers per second after being ejected from its birthplace in the Orion OB1 association, which includes the stars in Orion's belt. This runaway star is creating a bow shock that is more than 4 light-years wide. The angular size of an extrasolar star's photosphere was originally measured for Betelgeuse in 1920. The range of determinations is attributed to non-sphericity, limb darkening, pulsations, and varying appearance at various wavelengths. Subsequent studies have reported an angular diameter, that is, apparent size, ranging from 0.042 to 0.056 arcseconds. a complex, asymmetric envelope that is roughly 250 times the size of the star is also present around it. This envelope was created by the star's own mass loss. Only R Doradus and the Sun have angular diameters greater than those of Betelgeuse as viewed from Earth. In astronomy, determining the distances to red supergiant stars like Betelgeuse is a challenging task. For a number of reasons, it has been difficult to determine Betelgeuse's exact diameter. Being a pulsing star, Betelgeuse's diameter varies over time, since limb darkening causes the optical emissions to change in hue and become less intense the further one extends from the center. The star lacks a clearly defined edge. It is also challenging to characterize the photosphere of Betelgeuse due to the circumstellar envelope, which is formed of material ejected from the star and emits and absorbs light. However, it is challenging to compare one finding with another because the star's apparent size varies depending on the wavelength used. Measurements can be made at different wavelengths within the electromagnetic spectrum, and the difference in reported diameters can be as much as 30 to 35%. A massive gas plume that extended 30 AU from the star into the surrounding atmosphere was visible in photos collected by the ground-based Very Large Telescope Interferometer (VLTI) in July 2009 and made public by the European Southern Observatory. This mass ejection, one of many happening in the atmosphere around Betelgeuse, was the same size as the distance between the Sun and Neptune. At least 6 shells have been found to surround Betelgeuse, according to astronomers. It may be possible to identify the causes of these stellar giants' violent deaths by unraveling the enigma of mass loss during the latter phases of a star's life. Questions have been raised regarding the intricate dynamics of Betelgeuse's extended atmosphere in addition to the star's diameter. Red supergiants are a major contributor to the recycling of the mass that makes up galaxies, but the mechanism by which mass is lost is still unknown. Astronomers might be close to addressing this puzzle thanks to developments in interferometric techniques. Hubble and other telescopes were used by astronomers to determine that the star blasted off a significant portion of its visible surface in 2019 and created a massive surface mass ejection (SME). This is a behavior in a star that has never before been observed. In a phenomenon known as coronal mass ejection, our Sun periodically throws out portions of its flimsy outer atmosphere, the corona CME. Compared to what was observed on Betelgeuse, those events are orders of magnitude weaker. The reason is that compared to a conventional coronal mass ejection CME, the Betelgeuse surface mass ejection SME ejected 400 billion times more mass. Betelgeuse started to dramatically decrease in October 2019, and by mid-February 2020, it had lost around 3 times as much brightness, from magnitude 0.5 to magnitude 1.7. Betelgeuse's brightness had been stable for almost 10 days by February 17th of 2020, and the star was beginning to brighten once more. But Betelgeuse seemed to have completely stopped dimming 5 days later, effectively terminating the dimming episode. The recent visual fading appeared to be unconnected to the lack of major changes in the infrared on February 24, 2020. This indicated that an expected core collapse may not be imminent. The star's dimming may be most likely attributed to occluding large-grain circumstellar dust, according to another research that day. A study that makes use of observations at sub-millimeter wavelengths disqualifies dust absorption from having a significant impact. Large star spots, however, seem to be the reason for the fading. Follow-up research revealed a sharp increase in Betelgeuse's brightness. Betelgeuse is almost unobservable from the ground between May and August because it's too close to the Sun. Betelgeuse had a brightness of plus 0.4 before it entered its conjunction with the Sun in 2020. The star had dimmed by 0.5 since its previous ground-based observation in April, according to observations conducted with the Stereo A satellite in June and July of 2020. This caught everyone off guard because a projected maximum was for August-September 2020, and the subsequent minimum was supposed to take place around April 2021. Predictions were challenging because Betelgeuse's brightness was known to fluctuate erratically. The fading appears to suggest that a subsequent dimming event could happen considerably sooner than anticipated. On August 30th, 2020, astronomers announced the discovery of a second dust cloud emanating from Betelgeuse, which was connected to a recent, significant reduction in the star's light. A cool patch on its photosphere was proposed as a potential explanation for the dust in June of last year, and in August, a second independent study verified similar findings. The cooling of the star's ejected gas is assumed to have produced the dust. Occluding dust may have been produced by a surface mass ejection, according to a 2022 research conducted with the Hubble Space Telescope. The star's surface mass ejection threw material millions of kilometers out, where it cooled and condensed into the dust that made the star faint. The fragmented photosphere, which was roughly several times as heavy as our moon, flew off into space, cooled and formed a dust cloud that obscured the star from Earth-based observers. Even backyard watchers who watched the star's brightness change were able to easily detect the fading, which started in late 2019 and continued for a few months. The supergiant's 400-day pulsation rate has disappeared, which is even more amazing. Astronomers have been measuring this rhythm for about 200 years, observing changes in Betelgeuse's brightness variations and surface motions. Its disruption demonstrates the blowout's intensity. Now astronomers have put together a possible explanation for the disruption. Additionally, the star is still regaining strength slowly, and the photosphere is regenerating. The star's regular cycle is being disturbed, and the inside is resonating like a bell that has been struck with a sledgehammer. Betelgeuse continues doing some very unusual things right now. The interior is sort of bouncing, said Andrea Dupree of the Center for Astrophysics, Harvard and Smithsonian in Cambridge, Massachusetts. These new discoveries provide information on how red stars lose mass toward the end of their lives when their nuclear fusion furnaces exhaust, leading to their eventual explosion as supernovae. Their fate is highly impacted by the degree of mass loss. Betelgeuse's unusually obnoxious conduct is hardly a sign that the star is poised to go viral anytime soon either. Therefore, a large-scale loss event is not always an indication of an impending explosion. A convective plume that was more than 1 million miles across and boiling up from the star's interior may have generated the colossal outburst in 2019. The cooling portion of the photosphere was blown off by shocks and pulsations, leaving the star with a sizable cold surface area beneath the resulting dust cloud. Currently, Betelgeuse is having difficulty healing from this wound. Dupree hypothesizes that the convection cells inside the star, which are responsible for the regular pulsation, may be sloshing around like an unbalanced washing machine tub. The surface is still bouncing like a dish of gelatin dessert as the photosphere rebuilds itself according to TRES and Hubble spectra, even if the outer layers appear to be returning to normal. Astronomers have never seen such a significant portion of a star's visible surface get blown into space, despite the fact that our sun occasionally experiences coronal mass ejections that blast off small chunks of its outer atmosphere. As a result, coronal mass ejections and surface mass ejections can occur at separate times. Dupree is currently piecing the star's obstinate conduct before, after, and during the eruption together into a coherent narrative of a hitherto unheard colossal convulsion in an old star. The Stellar Robotic Observatory, the Tillinghast Reflector Shell Spectrograph TRES at the Fred L. Whipple Observatory, the Solar Terrestrial Relations Observatory spacecraft, Stereo-A, the Hubble Space Telescope, and the American Association of Variable Star Observers, AVSO, have all contributed new spectroscopic and imaging data to this. Dupree highlights how important the Hubble data was in helping to solve the puzzle. We've never before seen a huge mass ejection of the surface of a star. We are left with something going on that we don't completely understand. It's a totally new phenomenon that we can observe directly and resolve surface details with Hubble while watching stellar evolution in real time. The ejected material may be visible to NASA's James Webb Space Telescope as it continues to move away from the star in infrared light. Betelgeuse's fading has now stopped and might restore its position as the 10th brightest star in the night sky. Despite being far away, Betelgeuse is one of the brightest stars in the sky due to its inherent brilliance. It is around 100,000 times brighter than the Sun. Such brilliance has a cost. Because of Betelgeuse's immense energy, its fuel must be used up rapidly, hastening its demise. The star will eventually run out of fuel, collapse under its own weight, and then explode spectacularly as a supernova. And when it does, Betelgeuse will become extremely bright for a few weeks or months, maybe matching the brightness of the full moon and becoming visible in the daytime. When will it happen? Most likely not during our lifetimes, but in fact, no one really knows. It could be tomorrow or 1 million years from now. But will Earth be destroyed by the Betelgeuse supernova? No, when Betelgeuse does explode, it will be too far away from Earth to hurt or even partially extinguish life on the planet. According to astronomers, we would need to be 50 light-years away from a supernova for it to be harmful to us, and we know that Betelgeuse is over 10 times farther away than that. Anyone on Earth at the time will instead be treated to an incredibly stunning sight in the night sky of a very, very bright star. Finally, Betelgeuse's proximity will make it possible for astronomers to study the star after its supernova. Let us know what you think in the comments section below.